Right, so if you are looking at Bronsted, Lowry, um, Lowry, how do you spell Lowry? Reactions with regards to indicators. So an indicator depends on what you're adding to it. So an indicator can be in sort of like a base form, so it's ready to accept a proton, or it can be in an acid form, so it can donate a hydrogen. So indicators are weak acids or weak bases. So in this case, it's an acid. In this case, it would be a base because it could accept a hydrogen. So if you're adding something to an indicator, it depends on what you're adding. So if you add an acid, let's add, say, nitric acid, then which of these things would be able to accept that hydrogen from nitric acid? Um, Actually, nitric acid, you'd probably wouldn't write it like this. You would write it as a hydronium ion, because the strong acids, anything above that line, you typically write them as a hydronium. Anyway, so hydronium ion, so which of these things would be able to accept that hydrogen? And it's going to be this one. So you'd write the hydronium plus this form of the indicator, and then you do the Bronsted-Lowry thing to say this guy's going to give a hydrogen, and this guy's going to accept it. So if H3O plus gives a hydrogen, it becomes water, and the indicator becomes HLN. So, and the nice thing with indicators is this would be one color, and this would be a different color. Now, if you had a base, so if you have a base, and let's say it's sodium hydroxide or something, so there's a hydroxide ion, then which of these guys would have a hydrogen that it could take? Of course, it's going to be that one. So you would say plus that form of the indicator. So this guy's going to accept the hydrogen. He's going to steal that one. So it'll become water. And this thing here will become the other form of the indicator. And again, this is one color. This is a different color. So if you add a base to it, it's going to change. So this is the color that you're going to see in the beaker. Okay, hopefully that makes sense.